Hello and welcome. Today we're going to be focusing on a room in TryHackMe centered around a Conti ransomware attack on an Exchange server. Now, before we can jump into that room, start hacking, start getting all technical, what we need to do first is we need to explain what these two terms mean. And by these two terms, I mean what is ransomware and what is an Exchange server, right? Those are the two prime pieces that are going to go into the attack that we focus on today. So, to start off, let's start with the interesting part. What is ransomware, right? It's this big scary thing, right? Obviously, you've probably heard of ransomware before, but at the end of the day, all ransomware is a malicious software that encrypts files on a victim's computers or network, and it makes them inaccessible, right? So basically what's happening, I don't know if you've ever had an experience maybe on a personal laptop where you had some scary message pop up and you couldn't access your computer's files anymore, right? If you have, then that's ransomware. And this is something that a lot of users face and a lot of businesses face too, right? And we'll talk more about the prevalence of it later. But it's actually quite a common occurrence, not only for the enterprise world, but also for people in their day-to-day use. I know back in the old days when torrenting was very popular, a big thing was a lot of times through torrenting sites, people would get these attacks and it would say some scary message, and we'll see an example of it in a second, but it'll say some scary message like you have 20 hours to pay, or else your files will be gone forever. And it really leans in heavily on that intimidation piece. Now, as we were just talking about, as to the second bullet point here, the attacker typically demands a form of payment. This payment usually comes in the form of Bitcoin or Western Union, because these services tend to be notorious for being a bit more anonymous. Unfortunately for our attackers here, they can't just Venmo request us. They can't ask us to write checks for the payment, right? That'd be much more traceable. And when you're committing crimes, you probably don't want it to be traced. You don't want to have anything that could implicate you even further than what you've already done, right? So that's why a lot of times these attackers request Bitcoins in Western Union. If you've ever been wondering why, that tends to be their go-to form of payment. Next up, and this is a bit controversial in the cybersecurity space. So these attacks, they encrypt your files, they ask for payment. The next question is, should you pay, right? Why or why not? Now, the obvious answer as to why you might want to pay is a lot of times people want their files back. Most people, and a lot of times businesses, don't back up their files. They don't have another copy of their files somewhere out in the ether, whether it be on premises or in the cloud. A lot of times the files that have been encrypted, they need, and those are the only instance of those files, right? So it can be pretty tempting to pay the ransom right away. Now, a counterpoint as to why you might not want to pay that ransomware is, firstly, by paying it, it can encourage further attacks in the future to you or others, right? So let's start with the you piece. If I show that I'm willing to pay the ransom, an attacker might go, hey, why don't I just hit this guy with ransomware again in a month and get more money? And it's a valid question, right? If I've already showed that I am unwilling to back up my files and willing to pay a ransom, I might be a prime attack for future, or prime target for future attacks, right? And what it does overall, right, is let's put the individual away and look at it more from a collective idea. If everybody is paying the ransom, this suddenly becomes a very lucrative business model for attackers, and ransomware attacks will be encouraged even further. Another piece, another argument as to why you might not want to pay the ransom is because, and this might come as a shock to a lot of people, people can lie, right? Unsurprisingly, someone who is willing to hack into your machine, commit a crime, and put this malware on your system, they're also probably willing to lie to you. And if you pay the ransom, they may not decrypt your information. There have been some instances where, script kiddies or inexperienced hackers have infected people with ransomware, and then they got their payment from the ransomware, and they didn't actually know how to decrypt it, right? They didn't have the decryption key for whatever reason. So there are also examples where attackers lie, right? You may pay them, and then they might say, ooh, actually, we changed our mind. We want more money. Or they might say, no, I'm not going to decrypt your files. They might just say that to you. And then you're in a tough spot. Now, arguments for paying the ransom, right? We went over one before. What if it's your only instance of the information and you need it, right? That is one argument for paying the ransom. The next one, and this one's a bit more sensitive and much more important. Ransomware attacks occasionally will attack hospitals, or they will attack facilities in which any downtime can lead to a loss of life. Suddenly, this conversation becomes much more crucial because not paying the ransomware could genuinely lead to people dying, right? If a hospital is in literal lockdown and can't continue its day-to-day actions, people's lives depend on that. And suddenly that ransomware payment seems much more enticing, right? It seems much more enticing to at least have the short-term fix, worry about the long-term issues later down the road, but make sure that we're saving lives in the present. And that's why it is a bit controversial, right? There is a lot of conversation surrounding what we should do. Now, if you were an imaginary student, a question you might ask me is, how do people get hit with ransomware attacks in the first place? How does this occur? How did we find ourselves in this situation? And the answer is typically the same as it is with most issues in cybersecurity, and a lot of times the issue starts with the user. You've probably heard this before, right? In any security course that you've taken, or honestly, if you've worked a job and had to go through any of those cybersecurity awareness courses, you've probably heard or know that at the core of most attacks, most breaches, most cybersecurity related issues, there's usually an end user doing something wrong. Is that the end user's fault? Sometimes it's 50-50, right? At the end of the day, it is up to companies to educate their users and make sure that they're equipped with the knowledge of how to do things the right way. But in the case of ransomware, a lot of times these attacks come through phishing emails with malicious attachments. For those who don't know, phishing email, basically it's an email that's made to look authentic, and it's supposed to get a user to click on some sort of link, get some sort of download going to compromise their system. So for ransomware, that tends to be a pretty common vector to get in. Now, to the last bullet point, according to IBM, ransomware on average costs around $4.5 million. Now, that is an extraordinarily high number. And one thing to keep in mind is it is an average. If a mom and pop ice cream shop is attacked with ransomware, chances are there isn't $4.5 million worth of damage to even do to that business, right? So that wouldn't occur. But since it is an average, we also have those companies that are ginormous, right? Let's talk about like a Target or a Costco, right? If they get hit with a ransomware attack, I bet you it's probably going to cost them much more than $4.5 million, especially if it's on them for more than, let's say more than 12 hours, honestly. When it comes to calculating this cost, you might wonder, 4.5 million, like how do we even arrive at that number? The first is going to be the cost of business disruption, right? Think about Costco. If Costco is forced to have its store shut down even for a day, let's say it had closed all its stores down due to some cybersecurity related issue, and they had to do so for a day, that would cost them millions upon millions of dollars just for that day. We also have an example of Yahoo.com. They were hacked by this hacker named Mafia Boy back in the early 2000s. Might have actually been late 90s, I forget. But they were down for, I believe it was 12 hours, and it cost them tens of millions of dollars, right? So when it comes to the cost of ransomware, the first cost is going to be the cost of the business disruption. After that, it's also going to be the cost of all of the legal fees you might incur from leaking your customers' information, right? Let's say you are Equifax, right? Let's use an example we all probably know. Let's say you're Equifax and you're hit with this ransomware attack, and this information's been leaked, right? And this personally identifiable information is now out in the open. You will probably incur a lot of legal cost as well, not just business disruption cost, but also legal cost. Funny enough, the average cost of ransomware attacks here, when it comes down to it, IBM wasn't even including the cost of the ransom itself in this number, right? So you might also pay the ransom, and this number might even be higher for you. Now, last question before we move on to an actual example of ransomware here. How do we protect against this, right? We talked about how we find ourselves in this situation. How do we make sure that we don't find ourselves in this situation? And first answer is going to be regular backups, right? So we talked before about people get it affects people the most when they don't have backups, right? If you have all of your information locked and you don't have that information in any other place duplicated somewhere else, that attack suddenly becomes mission critical for you. If you have regular backups and now you're only losing maybe a week's worth of information, that suddenly becomes a different story, right? So regular backups is huge in terms of prevention, or at least in this case, more mitigation for the backups piece. For prevention, software updates is massive. When it comes to updating your software, this can close up vulnerabilities that otherwise would have led you to be compromised, right? So making sure that you're keeping software up to date is absolutely critical. And then last but not least, and this hinges upon what we were talking about before, employee training to avoid suspicious emails and suspicious websites, right? If we have a more educated and informed workforce, if we have employees that aren't clicking every link they're sent, we are in a much better spot in terms of our cybersecurity posture. Now, to talk about some actual ransomware, like what it looks like, and some examples of it, this right here is the famous WannaCry ransomware attack. It's a little image of it. Now, it has everything that you would want in any ransomware attack. It's got that lock icon on it, right? That scary big red lock, showing that your information's been encrypted. It's in all red to show you that this is an urgent message. It has this doom clock that's constantly just ticking down, showing how much time you have before your information's gone forever. And it even has these like paragraphs in the middle that make it seem like it's your friend, right? It's trying to show you how to get out of the situation. And the answer for getting out of the situation is, of course, one easy $300 payment of Bitcoin to the right address. So this is what ransomware looks like. Someone boots up their computer and this is all they see on their screen. They can't access anything else on their computer. So this is what they do. You know, a lot of times ransomware, it depends on intimidation, right? It has this sense of urgency. It's trying to force you to make a rash decision. And it's trying to give you some sort of sense of gloom and doom so that you feel helpless and pay it. Now, the article I linked here actually is one for you all to read up on later if you are interested. But this is actually a very interesting case of a ransomware attack. There was a ransomware attack that attacked a children's hospital. Now, if that sounds horrible, that's because it is, right? It's a pretty horrible situation. Interestingly enough, in this article, the ransomware actually, the ransomware group actually apologized for the attack later on. They said they didn't realize it was a children's hospital, and they actually punished the member that had put it on in the first place and not done their due diligence. So just an interesting read if you all want to do some further research on this. Okay, we talked about the juicy part, right? We talked about the attack. Let's talk about what is being attacked now, right? So we went from the actual method of attack, and now we're going to the victim themselves. In the case of today, when we go to the TryHackMe room, the victim is going to be an Exchange server. So what is an Exchange server? Basically, it's a product that focuses on sending, receiving, and storing email. It's a Microsoft product, and you all have probably dealt with this product before, right? If you used Outlook before, that is a user interface for it, right? And you probably have some experience at that point. Exchange servers, they are Windows specific, and they're also known for maintaining high availability by deploying load balancers. Now, what we mean by high availability here is basically think of Google, for example, right? If you are able to reach Google 24/7, it's never down, right? That is a highly available website. It's always available to you. If Google has some downtime, let's say it's down for a day, right? Suddenly their availability becomes doubtful. As you could probably guess with emails and Exchange servers by extension, you want that to be highly available. You don't want people to have emails that are lost or take hours to get there or maybe days to get there. So Exchange servers, they tend to maintain this high availability by deploying load balancers. And we'll see in a network diagram in a second where that sits. Also, as we were talking about before, Exchange users, they access and interact with these messages typically through an email client, the most common being Outlook here. Now, two things. If you've never used email before, one, I have a question. How have you avoided it for so long? That's honestly quite impressive. But two, if you've never used email before and you need a little bit more of an example of like what we're talking about, think of this Exchange server and its functions almost as like a postal service, right? It's a postal service for the online world. When it comes to sending emails, right, it functions pretty similar to a postal service in that there's an address it's being sent to, an address it's being sent from, and usually some contents that are meant to get from point A to point B, right? And the Exchange server typically is meant with ensuring that exchange goes well. Now, to move on from high level into a low level diagram that's a bit more complicated than it needs to be, this is what the architecture for an Exchange server might look like, right? We see different services that are interacting with it. We see that there's a split between client access, right, the things that you and I touch, and then back-end services, the things that we wouldn't touch as end users. And if you were an imaginary student, you might ask me, hey, Ryan, I recognize most of these things, except for what is POP3, IMAP4, SMTP. Those are like weird words, and I've never seen those before. To answer the question, these are different protocols with which mail can be sent back and forth. They actually stand for POP3 is Post Office Protocol, IMAP is Internet Message Access Protocol, and then last but not least, SMTP is Simple Mail Transfer Protocol, right? So these are all just different protocols used for this communication. And then last up, you can see on the left side of this diagram, we have, as we were talking before, that load balancer. Just to give you an analogy to help understand this load balancer, right? It distributes network traffic. The best way to think about it in my mind is imagine you go to Trader Joe's, right? And imagine Trader Joe's, as packed as it gets on Sunday at noon, it only had one cashier. That cashier would quickly be overwhelmed. People would not be able to access that service. It would take very long to get to the cashier and be able to check out. Load balancing is basically if you were to go from one cashier to 5, right? Now you can distribute that load or distribute those customers amongst 5 different cashiers rather than just one, right? And it's no different with emails, right? If you have one Exchange server, it might be overwhelmed, but if you load balance it and you have multiple servers to split this traffic, suddenly it becomes much more manageable. All right, that concludes us for the lecture portion. Now we're going to jump directly into the TryHackMe portion, and we're going to actually see some of this live. We're going to play with a ransomware attack. We're going to identify it, figure out what it did, and then, we're going to learn a little bit about Splunk as well. So I'll see you all in the next segment. Hello and welcome. So now what we're going to do is we're going to go through the TryHackMe room called Conti. So this is going to directly pertain to what we were talking about before. This is an Exchange server that was compromised with ransomware. Before I speak any further, what I'm going to do and what you all should do is I'm going to start up my attack box and I'm going to start up the victim machine, right? The reason for this is just so there's a little bit of a delay when it comes to booting these things up. Just so when I'm talking, we're kind of doubling up on productivity. We're learning about the room while also booting up our resources. So one of the things I like about TryHackMe is they like to give this task one with some context as to what we're looking at, right? So some employees from our company reported they can't log into Outlook. It seems the Exchange server system admin also reported this, and we find out that it is due to ransomware. Now, as we see from this note here, we have everything any good ransomware note would have, right? We have threats in it. It talks about how to contact their team, and it says, just in case you try to ignore us, we've downloaded your data and are ready to publish it. Now, obviously, this is a bad situation. Right? This is not something we like. So we're going to be figuring out how to go through all the events that pertain to this attack, right? What we also see down here is we have some information. We have username bellybear, password. You're actually probably not going to need these to log in. It usually logs into the Splunk server on its own. And then we have a Splunk URL. Before the box is provisioned, this will just say machine IP. So if it says machine IP and not a specific IP address, just remember to boot up this attack machine. Or excuse me, the victim machine here. Right? All you have to do to finish this segment is just hit question done once you have finished reading it. Next up, we have some questions about the attack. Right, so the first one is, here are some error messages we saw, right? This is what the users are seeing. And our question number 1 is, can we identify the location of the ransomware? What we're going to need to do for this, right, is we're going to use the Splunk server on our victim machine to figure out what is going on, right? To figure out what has occurred on the system, how did the ransomware get there, where's the ransomware, what is its hash, right? And then some other cursory information that we see here. So our attack machine is now booted up. What I'm going to do is I'm going to navigate to this Splunk URL. I'm going to boot up Firefox. And I'm going to type in http://10.10.10.79:9000, or excuse me, 8000, right? This is the port for Splunk. Now, obviously, your IP address is going to be different, is dependent upon the victim machine IP that TryHackMe provisions for you. So that is the only thing that will differ between what you're doing and what I am doing here. So keep in mind, even though the machine might be active, it seems like it takes a little bit for it to set everything up where these two machines can talk, right? So we have our attack machine here, and we are connecting to the victim machine. So just keep in mind that might take a little second to provision. All right, it is booting up Splunk. One thing I like to do, and this is just personal preference with TryHackMe, I like to hit view full screen, and it creates a new tab with just the attack machine, so I could view this in full screen, right? It makes it a lot easier. Whereas this like weird half screen model can cut off information. I like using the full screen here. So task number 1, identify the location of the ransomware. What we need to do is we go to Splunk, like I showed before, with that HTTP IP address and then port number, and then we go search and reporting. Now, if you are new to Splunk, you might type in index equals star, hit enter, and you might be distraught at the idea that there are 0 events, right? Because you were told that there should be something here. So a question that an imaginary student might have is they might say, hey, why are there no events when I do index star? I thought that index equals star means that I'm going to see all of the events, right? That I'll see everything in all of the indexes. And to answer your question, you're correct. But something that gets a lot of people off guard is in this top right corner where it says the last 24 hours. What you need to do is you need to change that timescale. It might be true that in the last 24 hours there were no events, but if we change this to all time, our story will quickly change. Right? And as you can see, we just went from 0 to 28,000 events. So just make sure you have the proper timeline in that top right corner here. Next up, what we're going to want to do, right? Once again, our task is to identify the location of ransomware. Typically, what you do is after you add the index, you're now going to look at source type. All we want to do with Splunk, right, is we have all of this information, just like this huge array of information, and we want to add filters to it to slowly whittle down the information so we don't have our SOC analyst looking at 28,000 events just to find like one thing of ransomware, right? We want to optimize this process. So what we're going to do is we're going to add one more filter. We're going to add the Sysmon filter. Why are we adding Sysmon? Sysmon's great for monitoring logging when it comes to system activity, right? So that's what we're going to use to see if we can find that ransomware. The next thing we got to think about is what is ransomware? Well, ransomware tends to be a malicious program, and a malicious program tends to be an executable. And when it comes down to what we're looking for, we're probably going to look for files that are with an exe extension. In Windows, in order for something to be an executable, it must end in .exe in its name. Now, that is not the case with Linux, and that does add some complications on our Linux systems. But luckily, since we're dealing with the Windows system, I can do this. We have now decreased the amount of events by tenfold. We went from 28,000 events to 2,300, right? And now I don't want to go through 2,300 events individually still, so we'll still add more modifiers, right? But this does greatly reduce our workload. Next up, what we're going to do is this information is formatted in a pretty ugly way, right? We have each event, and then we could hit show all 33 lines, and it's just a ton of information, some of which I don't even need, right? Like destination is IPv6 false. I don't need to know that, right? That's not interesting to me right now. So what we're going to do is we're going to hit shift \, which will give us a pipe symbol, and we're going to do table, and what do we want? We're going to want, let's take current directory, let's do command line, image, and then we have a question on hashes, so I'm actually going to add the hashes, right? If you're wondering where I'm pulling these fields, it's all from the interesting fields icon. So let's add hashes, and then lastly, let's do parent. Actually, let's do it over here behind command line. We're going to do parent command line. So basically what I'm doing is I'm cherry picking columns that I'm interested in. So instead of 33, just like lists of information, instead I'll see 6.
I didn't get that. Could you try again?
Oop, and my Apple Watch is interested in the lesson as well, it seems. All right, so this is what we see. We see our table. We see current directory, command line, parent command line. We still have 2,300 events, right? Keep in mind, all we did was reformat data. We didn't reduce it. So this is still quite a bit to go through. One thing I notice immediately from looking through this, especially when we look at Clean Manager, there are a lot of duplicates, right? We see, for example, Clean Manager had like 30 instances of it. So what we're going to want to do is we're going to hit enter, or excuse me, we're going to hit shift \, and we're going to type in dedupe and add that in here. what I want to do now, right, is I'm noticing there's still a lot of junk, right? There's a lot of duplicate entries that I'm not interested in. And I'm going to deduplicate, and let's deduplicate it based on, let's do it with the current directory. That'll probably be helpful. Let's do current directory and hit enter. Okay, we've now gone from 2,300 events to 5 events. And what we want to look through is each individual one and see which one of these is not in the right place. A lot of times with malicious programs, attackers will try to mask their program. They won't name it ransomware.exe. They'll name it something normal. Like they'll name it cmd.exe. Or they'll name it like, I don't know, any random executable that looks legitimate. The key giveaway that something might be a malicious program is if it is a legitimate program name in a weird location, right? So for example, let's look at, we see firefox.exe. This is currently in the program files Mozilla Firefox folder. That seems fine. Let's look at, what else do we got? That's probably the, Splunk, right? We see splunkd.exe, and it's in the program file Splunk Universal Forwarder bin. That looks fine as well, right? The one that's sticking out to me immediately is this cmd.exe executable that's in our documents folder, right? Like it's a little bit weird that we have our cmd.exe in our users administrator documents directory, right? So that's something that jumps out to me, right? So right off the bat, when it comes down to question 1, can you identify the location of the ransomware? It's going to be in here, right? So all we're going to do is we could copy this, copy, paste, and let's do cmd.exe and hit enter. I did spell it wrong. I put an R at the end, but luckily TryHackMe is forgiving. But this is the ransomware, right? Once again, it is a legitimate name program in a strange location. One other thing that jumps out to us, and this is going to matter later on, is in that same command line, we see that there's this other command to an .aspx file, right? Some .aspx file, and it also has to do with our Exchange server, right? So this is also very interesting to us. We're going to return to this in a little bit, but something to keep in mind for sure. Next up, what we want to do, what is the sysmon event ID for the related file creation event? Now, this is not something we're going to find in Splunk. This is going to be a little bit of Google foo. I'm actually just going to copy and paste this question because it's formatted pretty well, and we will see quite quickly that the event ID is 11. Right? So the answer here is going to be 11. Question number 3, can we find the MD5 hash of the ransomware? Now we know the location of the ransomware. So if we go back here, we know the location. All we need to do is find the hash, right? We've already determined that this is the location, right? It's the cmd.exe in the documents folder. That's weird. Luckily before, when we were making our table, we were diligent and we added the hashes here, right? We added that hashes column. So all we have to do is copy this MD5 hash, right? That's all we're looking for. Keep in mind, you can't copy this whole thing because we have the MD5 hash here. We have the SHA-256. We're only interested in the MD5 because that's just what the question's asking for. But there are other hashing algorithms in here as well. So let's paste that, hit enter. Next up, was the file saved to multiple folder locations? This is where TryHackMe is. It's a cumulative exercise. We're going to use the sysmon event ID for file creation to find what file has been created in multiple folder locations. I'm going to go back here. I'm going to clear this out. I'm going to keep everything, or get rid of everything except for the sysmon part, right? We're back to 2,600 events. Now I'm going to look into our interesting fields and see if there's anything that has to do with event ID, event code. We see right here, event code for sysmon. And I'm going to click 11, right? Because that's the event code that we determined has to do with file creation. So these are all the file creation events now, right? And let's look at, I'm going to do shift backslash to get our pipe. And let's make another table, right? Once again, this is ugly way to format everything. let's do table, and then the two things we're going to want, right, if we look here, is we're going to want images, right, because we want to see the executable used. We're probably going to be looking for, because our ransomware is cmd.exe, we're probably going to look for cmd, right, but we'll figure that out as we go. And then the other thing we're probably going to want to know is the target file name, right? So the two things we're looking for with this problem, with this saying what file was created in multiple locations or saved to multiple locations, is we want to find, firstly, what is the executable that was used in order to create these files, and secondly, what are the file names. So I'm going to do table, image, and then we're going to add target file name as we discussed before and hit enter. Okay, we're not interested in clean manager, all this. Hit next. All right, a lot more clean manager. We use PowerShell. We're going to hit next. All right, quite a bit of stuff. Now we see cmd.exe, right, and we see all this information. Now our answer here, right, we found out before that the ransomware is the cmd.exe executable, right, or at least it's named that in that documents folder. The file that's being created in multiple locations is readme.txt. Now let's say instead of like 6 pages of events, we had like 600 pages and we couldn't just click through them like I just did. What we could do is instead of just having event code equals 11, we could add cmd, and hit enter, and that'll narrow down our search immediately, right? Once again, going back to what we're looking for, we're using the information we found previously and continuing our search with it, right, to make sure that we keep narrowing it down, right? So we use the event code we learned about earlier for file creation. We're now looking for the cmd executable because we know that's the ransomware and that's the thing that's going to be creating these files sporadically. And now we see readme.txt is the file name. So I'm just going to type in readme.txt and hit enter. Okay, this one's interesting. What command did the attacker use to add a new user to the compromised system? I'm going to take this add a new user. We're going to go back to Google, and I'm going to do what is the event ID for add a new user. And we're going to see when a user is created in Active Directory, event ID is 4720. All right, we can click on this to learn a little bit more. So 4720 is what we're looking for. And if we read through this, that looks pretty good, right? What I'm going to do now, I'm going to clear the search out, right? We're going to prepare for the next question. I actually got rid of the source type 2. We're not going to be using sysmon for this. We're actually going to be going to the win event log security logs. This is what's going to monitor our user creations, deletions, and stuff like that, and group permissions. Right? So I'm going to add index, star, we keep always, added the source type, win event log, and now we're going to add that new event code we just learned about, which is 4720. Now, if you're asking, how did I know I could do event code equals 4720? Well, I see event code is a field here, therefore I could type it that way. You could also click, right? If you don't want to type everything out, you could click and choose the event code. But since 4720 isn't a top 10 value, it's just easier in my mind, honestly, just to type it out like this. Now when we hit enter, we see that there are going to be 2 events, right? 2 things to look at. I'm not going to make a table for this because it's easy enough to look at 2 events. So if I look at the first one here, we could see there's a ton of information. If I really wanted to only look at like the relevant information, what I'm thinking of when I look for user account creation is I'm curious what the user created was, like what their name was. So I could go to, what is it, account name, and hit this. So honestly, this is all the information we're going to need for this particular search so far, right? So all we have here is we see there are 3 pretty legitimate looking names, then whatever Security Ninja is, right? This is what I'm probably most interested in. If we look at this event here, this is actually the one that's associated with Security Ninja, right? So now what we're going to do is we're not quite at our answer yet. We don't have the exact command used to add a new user. We do have the new user, right? And we're going to just use this information actually to continue our search. Now what I'm going to do is I'm going to clear all of this out. I'm going to go back to sysmon as my source type, and I'm going to use the information we just discovered, such as that there's a user named Security Ninja. I'm going to type in Security Ninja. And I'm going to use this to find the exact command ran. Now, if we look here, event code 6. See, keep in mind the event code is different in Sysmon than it is in the Windows security log, so just keep that in mind. But if we're looking through here, we can see there are a couple of commands that have to do with Security Ninja. One has to do with local group, net local group, net local group. And then the other is what we actually are looking for, which is net user add. Right? We see net user add Security Ninja, and then they added it with hard to hack 123 $ as the password. So this is the command we're looking for. So I'm just going to copy and paste this here, hit enter, and we are good to go. Next up, the attacker migrated the process for better persistent. For those who do not know, persistence is an attacker's ability to stay and maintain access on a system. A lot of times attackers will use things called backdoors. What they'll do is they'll put, maybe it's like a cron job on a Linux system, right? It's something that runs every couple minutes to connect back to your machine. Sometimes it's user accounts, right? They added this Security Ninja user account in order to have a backdoor back into our system. What we're looking for now is going to be a process image that the attacker used, a migrated process image, and then the original process image the attacker created when they got onto our system. So let's go back to Splunk. I'm going to clear out all of our information once again, except for we're going to leave Sysmon this time. So we're leaving Sysmon in index. And what I want to do now is we're going to need to understand what is the event ID for process migration in Sysmon. Let's go back to Google. What is the event ID for process migration in Sysmon? Hit enter. And we find out Sysmon event ID 8, create remote thread. This indicates the source and remote or target process. This looks like what we're looking for. So let me go here. I'm going to do event code. Let's do 8. And luckily for us, there are only 2 event codes here. Let's expand it and see what we're looking at. So we see LSAS here. And then we see unseccap.exe, right? So we see these are the 2 answers we're looking for. What I'm going to want to do, I'm going to format this so it's a little bit nicer. This is kind of ugly in the answer. It's a 2-part answer, right? They want us to do the original process image and then the migrated and then the original. So let's go, let's do a table here just to make this a little bit pretty for us. Do table, let's do source image, right? So we get the original and then target image, which is the migrated. Hit enter. All right, so this is a much cleaner look. And it looks like what they did was they went from PowerShell to unseccap.exe, and then they migrated to lsas.exe, which we'll learn more about in just a minute. So for our answer, I'm actually going to take, we started with PowerShell.exe, and then went to unseccap.exe. Let's do that. Make sure we take the spaces out. And those are our answers. Right, so keep in mind we went from PowerShell to unseccap.exe, right? And then we can see later on we went from unseccap.exe to LSAS. We're going to get to the LSAT piece in just a minute. And by that minute, I actually mean right now. The attacker also retrieves system hashes. What is the process image used for getting the system hashes? This is where, once again, we can do a little bit of Googling. So let's do I'm going to make it a little bit leading, right? We understand from what we're looking at here that ultimately the attacker went to LSAS, right? They got to this LSAS target image. If we do a little bit of investigating about LSAS, can lsas.exe get hashes, right? We can actually find out that lsas.exe is used or can be used by attackers to extract credentials and or hashes or both. And that's actually the executable that our attacker used. So our answer for the next one, we actually don't have to change anything about our Splunk query. We could just copy and paste this target image and paste it right here. what is the web shell the exploit deployed to the system? Before we actually saw it, right? We saw it all the way back when we were looking at that command.exe. We saw that there was this .aspx file, and we're about to learn a little bit more about it. Right, so if you want to research more, you could always do, what is a ASPX file? Right, and you'll find that it's used by web servers for requests from the internet. If you did a little bit more research about ASPX files in the context of cybersecurity, you might find that a lot of them are, a lot of web shells are in that format. They're in the .aspx format. So honestly, in order for us to get that information, all we need to do, we can clear out all of this info with our query. I'm just going to look up ASPX files, right? Remember, this is information we found earlier when we saw that cmd.exe command, or excuse me, executable that had created this ASPX file. When we go here, right, we see this is the web shell itself, right there. Let's copy it. Paste it in. All right, this is the web shell. Right, once again, how do we know this is the web shell used to exploit the system? Well, it's a .aspx file, which web shells typically are in the format of. And it's also the one we saw before that was ran by cmd.exe, or our ransomware cmd.exe. All right, so if we scroll to the parent command line, right, we see it's that cmd.exe executable here. All right. What is the command line that executed this web shell? Right, we're actually looking at it still. It's this whole command line. All you got to do is find that one directory, or excuse me, that one column. And then we copy and paste it. So in one query, we basically answer two questions here. All right. And then last but not least, what 3 CVEs did this exploit leverage? So let's do, this is a Google question. Obviously, Splunk's not going to tell us this verbatim. So let's do, what 3 CVEs did Conti leverage? There's going to be a lot of conflicting information on this because each attack is specific. But if we go to images, we can actually see, funny enough, this is what we're looking for, this image right here. It has the 3 CVEs used, right, as vulnerabilities used by Conti ransomware. And we could see we're using CVE 2018-13374. All right, so let me type that first one in. CVE dash. Let's see, what format do they want in? CVE dash 2018. Yeah, so they want the full thing. CVE dash 2018. Dash 13374, comma CVE dash 2020 0796 dash, comma CVE dash 2018. Last one is 13379. It looks like. All right, and that's everything. We've just completed this room. So hopefully that made sense. If you have any questions, let me know in the comments. And other than that, right, this whole room has been focused on the Conti ransomware. We saw how to solve it in Splunk. This room really only required our knowledge base to be that of Splunk and of a little bit of Google foo, right? A little bit of understanding how to Google in such a specific way as to get our information. But thank you all for watching, and I will talk to you all soon.